In three-phase generators, losses can be divided into electrical as well as mechanical. Now, electrical losses are all the aspects of the generator that electrically causes losses. The first one is your copper losses, also known as heat losses. The conductor actually is made out of copper, which has a specific resistance, and as it increases in temperature, its resistance will increase. This will limit the amount of current that the generator will be able to generate. Secondly is our iron or our core losses. These refers to all the iron in the generator. Now, the iron in the generator is used to conduct magnetic field lines. As it rotates in the magnetic field, the core will generate its own current. That current is called an eddy current, and it adds additional heat to the core of the generator. The final electrical is our field losses or our field leaks. This is caused by the fact that not all the magnetic fields in the stator actually cuts through the coils, and as a result there are unused fields, and those magnetic field lines we then called our field leaks or our field losses. Our mechanical losses, as the generator moves, it will generate a mechanical loss, and these are divided into friction. This friction could include the resistance to the motion because of bearings that might be worn or not properly greased and oiled, and then finally windage losses. Because of the rotation, air particles get trapped inside the rotating part of the generator. As a result, it tends to cause a windage loss where the actual air restricts the efficiency of the motion of the generator. In order to calculate the efficiency, of my generator, I say the efficiency is equal to the output power divided by the input power. I could also say that my output power divided by the output power plus my power losses. I can also say that my input power minus my losses divided by my input power is equal to my efficiency. And finally, I could calculate it as 1 minus P loss over P in. When we did RLC circuits, we learned that power factor which is cos theta is equal to the true power divided by the apparent power. When looking at this, we find that because the coils in the transistor are made out of literally inductors, we will have a power factor that looks like that with reference to the voltage and the current that's flowing out of the generator. This causes a lagging power factor in all generators as well as transformers and motors. Now, to overcome this lagging power factor, what we do is we take our coils that make up our generator. Remember, this is three-phased or three phases, and we connect into the circuit a capacitor. Now, the value of the capacitor along with the value of the inductor is, in ideal terms, a value selected so that the resonant frequency of this combination is close to the resonant frequency of the supply voltage that is being generated. That will cause that the inductive voltage, now with the capacitive voltage included, cause that there is a very small phase shift between the voltage and the current. This in turn causes a small power factor, and as a result we improve the power factor of the circuit, and as a result it will be cheaper to run or deliver power.